This is my continuing coverage of the Euclid Book 7 definitions, and what we're going to do is, you saw the comments probably on the last video from Booball1067. Okay, was she correct? Absolutely. Now, let me explain that to you. She is actually correct. Now, here's how this goes. When you're talking about even times even and even times odd, this, by modern mathematicians, would be considered an even times odd. Why? Because 2 is an even number and 1 is an odd number. But this guy right here did not consider 2 as a number at all. Whoa, what a surprise! So if we were to go by this guy's definition, this wouldn't even be listed in this list at all. None. Okay, so 4 is an even times even. 6 is an even times odd because 3 is an odd and 2 is an even, so 6 is an even times odd. 8 is an even times even, okay. 10 is an even times odd. 5 is an odd, 2 is an even. Now 12 gets a little more tricky. If we're to go by modern mathematicians, this is both an even times even and an even times odd. But not with Euclid. You say, you mean there's a difference between Euclid and modern mathematicians? You betcha. 6 can be factored out into 2 times 3. So you have 2 times 3 times 2, or 2 times 2 times 3. And because of that 3 right there, 12 is immediately knocked off his list. Euclid would not have considered 12 an even times even. Not at all. So, if we were to go by Euclid's definition, 12 is only an even times odd. But if we're to go by modern mathematicians, 12 is both an even times even and an even times odd. Okay? Now then, 14. 7 times 2. The 7 here is an odd, this is an even, so this is an even times odd. 16. 16 is 8 times 2. Well, 8 can be factored out into 4 times 2. So you got 4 times 2 times 2, which makes 16. And if you factor out the 4 again, you have 2 times 2 times 2 times 2, which is also 16. So 8 times 2 and 4 times 4 both give you 16. All of these are even numbers. Therefore, by Euclid's definition, this would be an even times even. Also, by our definitions, this would be an even times even. Okay? So, when you're talking about modern mathematicians, if you have a 6 times a 2 and it gives you 12, that's an even times even, as well as a 4 times a 3, which is an even times odd. So 12 is both an even times odd and an even times even. But if we're to go by Euclid's definition, 12 would only be an even times odd. And that's because of the factoring. And I know you guys know about factoring. If you've made it this far, you know about factoring. And if you don't, you should be ashamed of yourself. You should learn about factoring before you come back over here. Alright. Now, the next thing I need to introduce to you people before I go and introduce prime numbers, which I'm going to go ahead and introduce to you today. How were the numbers originally formed? The Arabic numbers is what we use in this. See how these numbers are shaped? Well, this is how the numbers were originally shaped. Why were they shaped like this? See that right there? There is one angle in the number 1. There are 2 angles in the number 2. There are 3 angles in the number 3. One right here, here, and here. There are 4 angles here. Well, there's 3 angles in the triangle, and there's one right underneath the triangle. Same thing with the 5, the 6, the 7, the 8, and the 9. Go ahead, pause the video, count these up, you'll find out that I'm telling the truth. Draw them out if you like, and you'll see I'm telling you the truth. Okay. Alright, now we're not quite done with that board over there. And there is absolutely no way I'm going to pronounce either one of these names. If you think you can pronounce these names, okay, you go right ahead, but I'm not going to go ahead and pronounce these names. They're Greek mathematicians, and I'm not going to even get into that. So, alright, Euclid definition number 11. A prime number is that which is measured by a unit alone. Let me say that again. A prime number is that which is measured by a unit alone. That is Euclid's definition. Now this was a hotly contested definition. First of all, remember, Euclid himself did not consider the number 1 as a unit. Well, he didn't consider it a number at all. Euclid did not consider the number 1 as a number, period. And this also holds true for this guy right here and this guy right here. Neither one of them considered the number 1 a number. Now, I just told you that this guy right here didn't even consider the number 2 a number. So, if he didn't consider it a number, then number 2 wasn't prime to him. Now, we all know it's prime, but he didn't think it was prime because he didn't think number 2 was a number. Nice, huh? So, how do we know all this? Well, this top guy, we're going to talk about him first. This guy that starts with the letter N up here, we're going to talk about him first. He wrote a book called Introduction to Arithmetic. He actually considered prime numbers as a class of odd numbers. Okay? And the reason why he did was because at the time, when he did all his calculations of prime numbers, every prime number turned up to be odd to him. Remember, 2 wasn't even considered a number to him. So since 2 was the only even number in the whole prime number set, and he didn't consider that a number, then all those other numbers were odd. Every last one of them. You will not find in his list, remember I'm saying in the guy's list, you will never find an even prime number in his list. Now, they had a lot of people that were a part of a group called the Pythagoreans. And Thymaeridus, okay, he viewed prime numbers existing only on a one-dimensional line. So he made this special one-dimensional line, and he showed you all the prime numbers that were associated with it. And then they had another word, and I should have written it down here, and I'm going to go ahead and write this. This Thymaeridus, I'll spell his name for you. It's Thymaeridas, okay? He considered prime numbers as, I'm going to spell this word out because I am not going to pronounce this. Okay. Now there's Thymaeridus here, okay? He considered prime numbers as this. Now I tried to look this up on the internet. There is absolutely no references to it at all, so I don't know what he was meaning by that. If you guys know, please leave me a comment below. But anyway, this second guy right here wrote about this guy right here and was talking about how these prime numbers were this. Now, modern mathematicians, on the other hand, would go by this. When you factor out the number 5, you have 5 times 1. The only way you're going to get 5 is to take 5 times 1. No other two numbers multiplied together will ever give you 5. And that's what we're talking about in prime numbers. The same thing with 7, which is 7 times 1, obviously. And if you had 11 times 1. So if you take 11 times 1, you get 11, so on and so forth. Now, there are ways to develop charts to show you how to find all those numbers. You can find them on a number line using very specific techniques. And this is where Booball 1067 and I are going to take you. Okay? But there's one other thing we wanted to say, at least I want to say here anyway. One of the ways that mathematicians viewed prime numbers was they were saying that these were like the first set of numbers in existence, and all other numbers are formed from these prime numbers. So if you took these prime numbers and started multiplying them together everywhere, you would form all the other numbers. Now remember, most mathematicians back in ancient times, from Euclid to the other guys that I was telling you about, they did not regard 1 as a number at all. So if we're saying that we're not going to even regard the 1 number as, you know, the big old number 1, let me say it again here. The ancient mathematicians didn't regard this as a number. This wasn't even a number to them. So, if we're to go by their definition, then all other numbers really could be formed from prime numbers. Alright? So that's how that goes. Alright? And let me go ahead and reference a little bit. I'm definitely going to talk more about this in my next video. And we're going to get a little more in depth. But as you can start to see where all this stuff comes from, you're getting some of the idea. Okay? Now, remember that Euclid himself considered 1 as a unit. He never really considered it as a number 1. Okay? So, there was no other divisor that could be used to divide prime numbers other than the unit. And remember also that Euclid did not write down a bunch of numbers. He didn't even write down numbers at all. He used magnitudes. So he'd draw out the big old 11 like this, and he'd draw the little bitty 1 like this, and he'd use this line to measure this big line. He would take this little line and measure the big line with it. That's how Euclid defined numbers. Wow! So there you go. Whew. Anyway, I will tell you more in a future video, so stay tuned.